Okay, so welcome. Hopefully if you have found your way to this video, you have some interest in the 1/14 scale 637 scraper that I have developed. Maybe you're considering building it, want to know a little bit more about it, would like to see what's involved. So the purpose of this video really is going to be to do just that, to give you an idea of just what it takes to build this as far as printer capability, tools, your ability as a builder, any type of special things that you will need. What it is not is an exhaustive build video. It's not going to be a video of me putting in every single screw and describing every little step. You need to know that there are not and will not be complete instructions for this. I don't really think that there need to be. With some good photos, I think this video, and then I plan to make a photo album with a few photos that I've taken along the way. Really, the parts only fit one way. I've tried to design everything so that it almost snaps together, screws line up, holes line up. I've done tons of revisions. Behind me, you can't see it. There's probably 20 pounds worth of scrap parts that I've made as I've gone through this, iterating, revising. So I've really done my best to make everything fit. I can't stand models with holes that don't line up, parts that don't fit. I've tried to be super aware of someone building this down the line and not assuming anything as far as them having any machining abilities or special equipment. So pretty much everything in here is going to be something that you either print or buy, or hardware and fasteners that are off the shelf. There's no need for you to have a lathe or a mill. I have those back here behind me, but I've tried to design it with everybody in mind and try to make it as universal as I possibly can. Having said that, it is an advanced build. There are a lot of parts, a lot of pretty discrete wiring, a lot of tiny little fasteners. But if you take your time, I don't think that there's anything here that's too tricky. I would call it an intermediate to advanced build. Hopefully by the time you watch this and I kind of step you through some of the techniques, you'll have a sense of if it matches your abilities or not, if it's something you're comfortable taking on. The other thing you need to know, it's a huge model. It is 1.2 meters long, basically just fractions of an inch under 4 feet long. I don't have a final weight, but it's over 30 pounds. That's going to depend a little bit on how much weight you add to it, but it is big and heavy. It does split in two in less than 2 minutes, so that's easy. You can divide it into two parts for transport and to get it up on the bench. That's certainly a nice feature that I'll show you here later on, but you need to know too that it's big. It's big, it takes up a lot of room. It is quite maneuverable, I found. It steers well and drives well, so that's great, but it is a big beast. So, all right, here we go. The very first thing, and probably the first checkpoint or gate post, if you will, that you need to be honest with yourself about is the tires. Are you prepared to make these? They are, in my case, a cast urethane tire. They come out of a mold that needs to be 3D printed. It really needs to be resin 3D printed, so it's a 6-piece mold. There's the what I'd call the bottom. I cast them with this down. There are 4 sidewalls that bolt together all around it, and there's a top plate that goes on it and a couple little funnels for pouring. It is not an overly difficult process. It can be a little bit daunting to pour this much urethane at one time if you've never ever done such a thing. I think it yields a really great result. It's a nice squishy urethane. It's nice and grippy. This tire is heavy. It weighs nearly 3 pounds. So it starts off with a 3D printed spider in the middle of it that is printed at 100% infill. It uses almost exactly half of a spool of filament, like 480 grams of filament. By the time you print 2 of these spiders with supports back to back, you'll have about 4 to 6 feet of filament left over. So I've tried to really optimize the fact that you could get 2 of them out of 1 roll of filament. The other option would be that you could, and I'll include separate files that would allow you to print a TPU tire if that's your choice. Obviously, the barrier to entry there is a lot lower. You don't have to make this mold. You don't have to have any experience or comfort level with casting, but obviously a TPU tire, due to all the layer lines and the way that it's going to look, it just isn't going to look as good. I also doubt it's going to be quite as grippy. Probably depending on your infill, you can get the squishiness right where you want it, but that's the first thing you need to ask yourself right off the bat. There are no commercial tires this size. The biggest tire that I found that has a construction appropriate, if you will, tread is about 142 millimeters in diameter. These are basically 170, so considerably bigger, nearly double the volume of the biggest tire that that you can find, that you can buy off the shelf. So I think that's part of the reason nobody's ever made a scraper before, maybe, is that these tires are a little bit unique. They aren't used on a lot of other pieces of equipment, and so they're just not super common, and nothing that that China has produced yet. So you've got to make your own. So that's really the first conversation you need to have with yourself. Am I prepared to make these tires? Am I prepared to print or cast them? And if not, then really this model, quite honestly, isn't for you. I started the design process with the tires. They're actually the very first thing I made, because for me too, that was the conversation that I had with myself is, hey, if I can't have these tires, if I can't make these tires, there is no point in me continuing on designing the rest of the model, even though I really wanted an earth-moving scraper. So having said that, if you think the tires are something you can accomplish, it's really all downhill from there afterwards. It is not that daunting. These are nice because they do add a lot of weight, at least in the case of the cast urethane ones. Like I said, nearly 3 pounds a tire, so 12 pounds, not quite 6 kilos for my metric friends. So a lot of weight down low, and that's really advantageous for the model, since it is a big model, but it's a big hollow open model, and so it needs all the weight and all the help it can get if you're going to try to scrape dirt. So, okay, enough about tires. Let's talk about the model. So you can see here I have what appears to be about 2/3 of the model on the bench here. In reality, it's probably about 2/3 of the work as well. The front section, which I'll cover later on here, is pretty dense, and there's a lot going on there. All the electronics are stored up in the front, besides these two motors, and all the drives, all the ESCs, the battery, everything else is up in the front. So really the back is motors in the motor housing, and I'm going to flip this over here, trying to keep everything in frame so that we can see it. Hopefully I've done okay job of keeping this framed here. Really, this is one big print, one big 12-hour print. Something about prints. It's not for me to tell you how to print things. That's up to you. I will tell you what I did. For anything that even resembles a structural part, I did 45% infill and 3 walls. Obviously, you can choose to print this however you want if you decide to make it. That's completely up to you, and I don't know what works best with your printing setup, but I have found that 3 walls and 45% feels, if you will, feels right. Everything seems stiff enough. Nothing concerns me that it's going to break or come apart. One notable exception, there are 2 very small little tangs up here. They're actually meant to be replaceable in just a few minutes should they break. They're a high stress area. I haven't broken them yet, but having said that, I do print them at 100%. And I accomplish that by doing like 8 walls, because that's a little bit stronger, I think, and then the little bit of infill that would be there is 100%. So there's still a quick print, like 20 minutes for those 2 parts, cost you pennies to make. So anything that is obviously decorative, like these covers or this cover for the bottom, I printed at a really low infill. Certainly you could go with a higher infill. Weight is your friend, once again, so get as much weight in there as you can. I have a 350 millimeter printer, a couple of them actually, that are over here running in the background. Sorry for the noise. Creality K2s, those are perfect for this. Every part will fit on a Creality K2, no problem. If you have a Bamboo X1 Carbon, super popular printer, I know, the only 3 parts that should not fit are the floor. Should you opt to do the printed floor, there's also an option for metal floor. We'll talk about that in a minute. And the 2 side plates. As designed, by the time this video is out, by the time the plans are out, I will have come up with a provision to divide those in 2, print them in 2 parts, and screw them back together. So obviously, ideally, if you have a bigger printer, you'd print it in 1 part, but recognizing that the X1 Carbon and other 250-ish millimeter printers are incredibly popular, I need to accommodate those as well. So I will, again, there'll be options in the files for both. One last note about printers, I highly recommend a smooth build plate. A lot of these parts are visible on all sides. So like the crossbeam here, this was the bottom. This was the bottom of the scraper edge. If texture doesn't bother you, no problem, use your texture plate. But for a lot of these parts, again, 3 or in some cases 4 sides of them are visible. So I really recommend a smooth plate. It just makes things look a lot better in my opinion. Again, your model, you build it, print it, design, do all that however you see fit. I won't tell you any more about that. Weight, I've put a good amount of weight in here. There's certainly room for more. You could pack more weight in here if you wanted to. Some people are great. I see pictures online and they get literally every little square inch is filled. So that's great if you choose to do that. Well, we've got it flipped over here. Let's look at the rear actuator. So I would install it with it extended. It's going to make it easier to put the ram on later, or the ejection plate on later. Wires should snake right down through this slot. Of course, it's on video, so I'm gonna struggle with it. I'm trying to keep my fat head out of the way. This needs to slide and should slide. I'm limited by the lengths of actuators that are available, and basically, long explanation short, if I wanted to keep the proportions of this scale, which I've strived to do, everything is absolutely as close to exactly 1/14 scale as I can, and if I didn't want to stretch the bowl, which I didn't want to do, I want it to be accurate, then because of the fact that this actuator is a set length, I needed to basically consume or use up some of its stroke. So there's about 10 millimeters or 3/8 of an inch here that is wasted, if you will, that's used up. So each time you change directions, once you've ejected and pushed all the dirt out, flip your switch or your slider, however you have your remote set up, and you're withdrawing the pusher plate backwards, you'll have a brief delay as this basically eats up its own movement inside. So you need to know that. Fortunately, this type of machinery isn't really one where you're cycling it back and forth a lot like you would be an excavator or bulldozer or something else. A lot of short movements. Pretty much it's going to be full stroke to eject and then retract that pusher plate. So it works well in practice and is really seamless when you're operating it. Everything is covered up with a plate on the bottom here. Put some screws in here. Let's talk about screws real quick. I'll put a description, or a link rather, descriptions in the bill of materials. Couple different ways you can build it. I've done it both ways. 3mm self-tappers. 98% of the screws in this are going to be 3mm screws. That's not accurate. Probably more like 95%, 90%. There are some 4mm in the motors, a couple 5mm, and then there are some tiny little 2mm screws as well. But the bulk of the screws are 3mm. I've used button heads as much as possible. The recesses are sized so that they will accommodate a just regular Allen-headed cap screw too. A couple of routes you can go. You can either use self-tappers. Those work great, especially with 3 walls as I've done it. Or you can actually tap these prints. The first one that I built start to finish, I tapped everything. So tap and just use a regular straight-threaded screw. That works well too. I told you didn't really need any special tools, and for the most part that's true. Hopefully you've got a nice set of drivers, nice set of hex drivers. Maybe you've even got a set for your drill. Those are helpful when you're putting in, lots of fasteners over and over and over. Obviously set the torque setting low and be careful. One exception is that I have relied heavily on this set of reamers, and you may not have these. I think they're 19 or 21 bucks on Amazon. I'll even put the file in there for this little holder that I printed. I have made extensive use of these reamers as I designed this and constructed this. So all of the clearance holes are printed at 3.1 millimeters, so a 3mm screw should go right through them. But you guys print, you know that holes, especially along the build plate, depending on how well you have your printer calibrated, tend to swell and close up a little bit. So those reamers are super helpful. It's 20 bucks well spent. I'd highly recommend you get them. You can blast through all the 3mm holes, ream the outside so your screws are a nice slip fit through there, and then all the holes that receive the screws are all printed at like 2.45, not quite 2.5 millimeters. So they're just right, either to tap or to use a self-tapping screw in. I think you'll find that those go well. So again, while you've got it flipped over, put this in, put your plate on. I'm going to take this out for now since I'm not actually capturing it with the plate. We'll flip over it and talk about the top. Forgot to mention before I flip it over, there's a cavity here with a plate that is glued and screwed. I have some of these stick-on wheel weights in there, and then I also filled the rest of it with BBs. So several 100 grams of BBs in there as well. Motors. Let's talk about motors. I used 30 RPM motors. I've gone back and forth whether 30 RPM or 50 RPM would be better. I would say if you're a guy that's gonna operate this on carpet and maybe use rubber like they do at a lot of the shows, 50 RPM is probably a better choice because you're gonna have better travel speed. It's gonna cruise right along when you are traversing from place to place. If you want to go out in the dirt and try to do actual work and try to actually dig and cut and scrape, then the 30 RPM is probably a better choice because you have quite a bit of torque. Obviously, when you go up in RPM, the sacrifice is you're trading off torque, you know that. So I've gone back and forth. I've opted for the 30 RPM. I may build another one with 50 RPM motors now, just because I kind of want to build a white one too. But anyhow, that's beside the point. Part of that conversation about dirt versus carpet with rubber, files are included for a 2-piece bottom here. This has a nice rounded, like a 1mm radius on it. Should be perfect for picking up rubber off a carpet without kind of tearing up the AstroTurf and causing problems. Also included will be the step file that you can send off to a laser cutting service. I actually just ordered my laser cut steel plate, like 2.6mm plate for the bottom. It was $37. Again, I'm here in the US, so all the prices and things that I'll quote will be in the United States. I think in Europe, laser cutting's not any more expensive. So if you opt to get that laser cut plate, if you want a steel plate, you really want to be out scraping the dirt, then that steel plate is going to be the way to go, and it'll allow you to take a grinder and sharpen the edge of it. To allow for strength and to not have the lip rip off of the steel one, I did design it as a flat piece. You'll see it has 2 little notches or dimples included in it as features. Those are going to indicate a bend line, and there'll be a 3D printed template that will allow you to put this amount of kick or this amount of bend into the steel plate. So it will require you to have a break or a means, or maybe a friend, or maybe you can go to a shop and have them throw this one quick break in if you do bend, I should say, should you choose to do the metal plate. Motor, super straightforward. They drop right in, put one in, add the screws. The other one just barely snakes in there, add the screws. There's this kind of stiffener here that stiffens up the chassis, 3 screws on there. Wire routing is, besides the tire, probably the hardest amount or the most challenging part of the build. It is difficult to route the wires, not impossible, but again, in interest of keeping things scale-like and having wires exposed pretty much only where hoses would be exposed on the real model, there's some internal routing here. I'll show you that from the side in a moment. And it comes through the head and out and through here. So snaking these wires can be the trickiest part. There are 2 24 gauge wires for the motor and then 4 30 gauge wires for the accessories, 1 for the ram, and then there are tail lights back here that I'll show you in a second. So those are the wires that are routed internally, and again, we'll look at that from the side. As far as the rest of the back, we've got this simulated engine, lots of room here for weights. You can pack, I think there's close to a pound there. Keep in mind your wire routing and leave some room for that, but there's room there for quite a bit of weight. And then here's the back part. You've got the push block. These are printed solid because I know a bulldozer or something is going to be hitting this. Maybe another scraper if you have a friend build another scraper, but pretty simple. It's 1, 2, 3, 4, 5, 6, 7, 8 parts. No big deal. Screws all together with screws. Super simple. Black grill. Everything else your body color. This I did print a little bit more solid to allow for some more strength there as well. And this will all slip together, snake together. I think you get the idea. It's going to be tough to do on camera, of course, but all of these will slip in. Couple button head screws here, 6 screws along the side, and then obviously the tires will slide on. They're held on by 8mm metal bolt-on flange hubs, like many of the models you've seen. It's a great technique. I found it works well. A couple set screws to hold that on the motor shaft. So I'm going to take this back off here in the interests of being able to move this around for filming. Come around to the side here. Let me see if I've got this in frame where you could see it. I think I do. There are cosmetic covers that will double-side tape and or glue on here, depending on how confident you are. A couple little dabs of glue should be fine. Again, these wires are routed through a channel here. They come out, I've got them bound together with some super fine floral wire to make them look more like a hose. I snaked a wire through here, tied all three of these together. There are 3 per side. 6 wires go to the back, 3 per side, a fat and 2 skinnies on each side. I soldered a skinny wire to it and used it to snake them and pull them through. I found that trying to shove them through there was difficult. I've made these channels as big as I possibly can, but to maintain these body lines and keep it as close to scale as possible, I just can't make them any bigger, unfortunately. So tricky, but definitely not impossible. There are cosmetic covers for right here. So once you've got all the screws in, you can see I've only got a couple, but once you put all 6 screws in there, these, again, double-sided tape or glue, they almost snap in place, but a little dab of glue should hold those. I've tried to cover up as many fasteners as I possibly can. There are a couple screws here. They'll snap in caps. Once again, they don't even need glue. Glue would be better, but they just snap in. So the socket-headed crap screws that hold this crossbar. I've tried to hide as many fasteners as I possibly can, and then the ones that are exposed, I've tried to use button heads. Let's talk about the ejector pusher plate. It runs on 2 recirculating ball guides here. They are pretty cheap, 10 bucks for the pair, easy to get. And then it runs on 2 8mm linear rails. Again, these are sized and the model is designed so that you don't have to cut these. You can buy them on Amazon, 10 bucks for the pair. Super easy to obtain, and no cutting. I've tried to make it so you don't have to cut or saw any metal. These should slide right in. Once again, everything's harder on camera, obviously, but you can see the pusher plate slides back and forth really nice. They're up and out of the dirt. They do have rubber wiper seals. Will they wear out eventually? Yes, probably. If you play out this outside with this in dusty, aggressive dirt, total cost of replacement for everything, should you wear it out, is 20 bucks. But they are Chinese. They're imported, but they're industrial parts. They're meant for tens of thousands of cycles. I can't imagine you're ever going to wear out a set, but if you do, should take you half an hour to change them, and 20 bucks. So tried to make things pretty replaceable. There are 4 holes to mount them. In practice, 2 is really all that's needed. There's not any force on these. They're just a guide. 1 bolt down here through your linear actuator, and you'll have your ejector plate hooked up. I'll get that out of here once again for filming. Crossbar bolts in. We talked about that already. On the side here, 5mm button-headed screws, so they're just a regular screw. There are recesses in the arm, and this bearing cap clamps around it, so it's just a very stock bolt. Super simple. I have found it is plenty strong. Thankfully, the machine's all-wheel drive, so although of course it's always pushing and pulling on itself, there's not as much strain on these maybe as you would think, since both halves of the machine are working. Let's see if I can keep this in frame here. I'm looking at my camera at the same time, sorry. The neck is involved. There's no 2 ways about it. There is a lot of wiring going on here. There's a lot of little tiny finicky parts because of all these clamps. If you use the wire that I suggested, you will find that it fits in the clamps quite nicely. It's slightly loose in all the intermediate clamps, and then what I did is for the very last clamp in a run where I want to keep things tight once all my wires are ran, I sanded the base of these clamps slightly before I screwed them down so that they have a pinching effect, so that you can kind of keep some tension and keep these hoses, simulated hoses, but obviously there's juice flowing through them. So keep those as nice and straight as you can. It really adds a lot to the look of the model. A little bit finicky to route them. I found it's best to put the clamps down, leave them loose, and use tweezers to route your wires through one at a time and just pull them through. It's not as bad as it looks. It's time consuming, but the end result I think is pretty favorable and is pretty enjoyable. Made the whole model split in 2. I kind of alluded to that earlier. An XT30 connector for the rear motors, and then this 10-pin pogo connector, magnetic pogo connector. If you haven't used these, they're great. So all 10 of the small wires run through here. A 3D printed cap is provided that allows you to heat shrink and bundle these all together. So that will go up to the front and attach to the front of the tractor. And really you could split this whole thing in two in less than 2 minutes. A friend had designed, had challenged me to be able to make it be disassembled in less than 15 minutes. And I said, well, I think I can do better than that. And honestly, you could split the whole thing in 2 minutes. It's these two connectors and one long bolt that runs through here, a 5mm bolt, 5mm Allen. And so really you pull this one bolt out and it comes apart super easy. Makes it a little more manageable for transport or when you want to work on it. These cylinders are actually just dummy cylinders. They don't do anything. The machine steers through differential steering, so you do need to have a transmitter capable of doing tank steering or differential steering. I think most modern computer radios do that no problem. I know the i6 will. I'm lucky to have a much fancier radio that allows all kinds of neat mixing and things, but even a basic computer radio should be able to do that. But just know that these are just dummy 10th scale crawler shocks. They should have springs in them. I've taken the springs out so they just move freely. The real machine moves like 85 degrees one way and 89 or 90 degrees the other way, and I've got about 88 or 89 degrees of articulation both ways here, so I'm super happy with the movement that I've got there. And the way that everything moves and twists and pivots. It's kind of neat to watch it drive over rough terrain and keep all four wheels on the ground. It's pretty cool. All of the smaller linear actuators, there are 3 of them. So one for the apron, which isn't in here right now. It's this big part. The yellow one's printing in the background. That's what you can hear. But this big apron that pivots, that opens and closes to keep the bowl open or closed. So that actuator and the 2 that raise and lower the entire bowl are the same. Those 3 actuators are the same. And then I know we're not talking about the front right now, but the actuator up front that drops the hoop or the toe loop down is actually the same actuator. So you need 4 of them the same, and then 1 giant long one. Again, those are all called out in the bill of materials. A couple button-headed cap screws here hold the whole thing together. Again, these parts here are the parts that I printed solid. So these 2 halves of the neck bolt together. There's a bunch of screws that hold it together over here. You can't see it, it's out of frame, but a cover plate, again, to hide those screws to try to make them less noticeable, or not noticeable at all. Really, you shouldn't see them once the cover plate's on. So should you break these tangs or wear them out, I don't know, probably 20 minutes you can change them out. No big deal. You'd have to split it part way open. They're kind of a T shape. They set in some recesses in there, but I did print those at 100% since those are the main place that all of the weight and force is distributed. But again, I found that really because the front end's heavy and the back end's heavy, even when it's full of dirt, it's pretty balanced. It doesn't seem to have a ton of strain in the middle, so it might look a little fragile, but I found that actually it's surprisingly good at keeping itself together. Now, having said that, real scrapers are probably, I think guys that work on them will tell you, one of the most maintenance intensive machines out in the real world. Everything is broken. There's always something broken on them. I'm sure that if you use this a ton, you will end up having to reprint and remake some of these parts from time to time, kind of as a consumable or wear item, but hopefully not too much. All right, I think that about covers it for the front. The only thing I didn't talk about is the fenders and the taillights. So I'll show you one of these. These taillights are just a simple print. My red's not ideal. I need to get a red that's a little more ruby red, a little more taillight red, less pink, so I'll probably redo those. But to make these, they're just one 5mm LED slid into them, fits right in the bore, and then I use a clear UV resin, just like a crafting or a jewelry doming resin, and I just put that in there and cure it with a UV flashlight. Gives a nice appearance. Depending on how you could figure the lighting, I'm just going to hook mine up so that these are on, just solid red whenever the model is powered on. I don't necessarily need brake lights to actuate, or I don't need flashers to flash or anything like that for a scraper. But should you choose to put some a lighting controller in it, there's plenty of room up front for that. You'd be able to control those as well. Again, there's wiring ran back to those from the front, so you could control those however you want, really. Okay, I think that that covers everything that we need to cover on the back end here. Hopefully it gives you a good idea of sort of my methodology, my thought process. I'm gonna stop the video now. There'll be another section where we cover the front, talk about the front half of the machine and what's involved up there. Once again, a lot going on in a small space, but pretty straightforward once again. So hopefully this gives you some idea, lets you know if this is a project that you want to tackle, something that you want to go for, or if it's not something you're interested in at this point. Hopefully by now you've answered that question, and if you continue watching, we'll cover the front end in a little bit of detail as well. All right, thanks. Okay, thanks for hanging in there. We're back, this time looking at the front. I'm going to try to make this part of the video a little bit shorter. I think covered a lot of ground talking about the rear 2/3 of the machine. Although there's a lot going on up front here, I'm going to try to be a little bit more succinct this time and show you some of the features. So obviously it's disconnected from the back of the machine, so I've actually got a plastic block glued underneath it. This is how I tested it initially when I was prototyping it before I built the back, and found out it worked pretty good, so I just hot glued that back on for purposes of the video here. I'm going to turn those beacon lights off actually on top of the cab, because those are probably not something you want to stare at while we do this. So let's talk about those first. Just cheap little China lights, 10 bucks for a pair on Amazon. The cab roof has holes for them. I did cut the wires off them and attach my own little 30 gauge silicone wires, this same super fine black silicone wire that I use for the lights on everything else, just so that as I ran it through the cab and down, it wouldn't be so noticeable. And there are holes on the top to accommodate that. On top of the cab there, the parts that you could see that are gray, I actually resin printed those, and the interior is going to be resin printed in my case ultimately. There's a few parts on the model, the handrails, which aren't on here right now, they attach magnetically, and then these detail parts, the cab interior, and these couple of ladders, really best resin printed. Certainly they can be FDM printed. I FDM printed the ladders for the back. I actually forgot to show those in the video when we were talking about the back, but you can do it. FDM will work. Resin looks a little bit better, especially for details like this fan grate up here. So I have the ability to do both, but it is not an out-and-out requirement. But for things like these steps, this step goes over on the side and swings up and down. It would be nice if you have resin printing capabilities, but you don't have to have them. Exhaust, again, is going to go up here. That's not attached either, so there's a few detail parts missing in the video here, but I think you get the idea. Let's talk about steering while I've got it powered up. So again, I mentioned in the first part of the video, you do need a computer radio capable of setting up tank or differential steering. I'm lucky enough to have this this beautiful FrSky radio here that does just about everything, but you could see I've got my steering set up as well as my throttle all on the left stick. So in practice, it's super easy to drive the machine and maneuver it, and the rear end just kind of follows the front end. I actually found out it works amazing, actually. Kudos to my friend Tony, who suggested I attempt to implement this solution rather than messing with actuators or some giant servo to steer the machine, and it works better than, honestly, better than I could have ever hoped for. And it's so simple and sturdy and elegant. It just does, again, require the computerized radio, but I think if you're looking to build a model of this type, you've probably already got that in your arsenal anyhow. So a couple other features up here. Let's do the front bail or the front hook. Again, the same actuator is in the back. This is powered, spring underneath here, so the little buffer plate, in real life there'd be grease smeared on that. My hope is that when we've got a couple of these, we'll be able to link them up and do some push-pull action, and so I wanted the front bail or hook to be powered so that we could do that. The hole in the actuator is M4. I've intentionally put an M3 bolt through it, and I've done that to allow just a little bit of compliance or a little bit of movement. Obviously, if these are together going up and down over stuff, I wanted a little bit of movement in there. So intentionally sloppy, intentionally built that way. take a look inside here, the hood. By the time you get the files, there will be a notch here that isn't shown, so keep that in mind. There'll be a notch there that allows for the routing of those wires from the back. We've got the same kind of connector here, this pogo connector. This attaches to that I showed you earlier. Again, the same housing goes around it. Hood will be held on with a couple of magnets just to keep it from rattling around. And I think if I get to it, I'm even going to put a spot underneath here for an Allen wrench. I had told you that you could take the entire model apart with one wrench in about 2 minutes. So you have to take out this bolt and, well, I dropped it there, but this bolt and this thrust washer. So you've got a 5mm bolt and a 4mm Allen wrench, and that is literally the only tool you need to split the whole model in half in about 2 minutes. So again, I'm going to try to incorporate a holder for a 4mm Allen wrench up under the hood. A 5000 or even a 5200 milliamp hour 3S battery fits in here beautifully. I've incorporated a panel mounted XT60 connector here, so you can plug in. There's a provision for a panel mounted switch here. So one button, super easy, turn the whole model on and off. I've also incorporated, shut off my radio here. I've also incorporated a circuit breaker. I feel like every model should have some kind of fuse or something, so you don't let the magic smoke out inadvertently if something goes wrong. And I like these resettable circuit breakers. I'll put a link for those again in the bill of materials. I believe I did a 20 amp in this case. You get an assortment for like $10 and it comes with several of them, but I like to use these in my models whenever I can. If something should happen, you're not stuck at a show somewhere trying to find a spade fuse or a glass tube fuse. You can just simply reset it should something go wrong. So kind of a nice little feature there. Just a little bit dusty because this has been out doing some work, so bear with me there. But again, detail ladder goes on the side here. There are housings for headlights. I don't have them in here yet. Same way, 3D printed housing, LED slid in from the back, and a clear dome lens, just like the taillights that I showed you a little bit earlier in the video. Made this handrail to attach with magnets, these little magnets, so the handrail cage. I've actually got one here on another model. This is an early version that was screwed on. I quickly realized that this is something that's going to be susceptible or prone to breakage, so opted for the magnetic route instead. That way you can take it off when you want to haul it, or if you bump into it or dirt clod or something hits it at a show, it'll pop right off and not break your model and ruin your day. So tried to incorporate some neat little features like that. Again, there's going to be a notch here, not shown yet. I didn't want to reprint the whole chassis just for a notch. I'll probably just cut mine, but the files you get will have a provision here to let these wires come through underneath the back edge of the hood and snake right in there. Moving around to the back side here. Simulated hoses, just some silicone wire. There are some fatter ones that go here that I've taken off. One piece of metal wire. This is just, I think, 2mm wire. I'll spec it out in the sheet, but fender stays, holds the fenders from behind. I broke my fender the other day getting it out of my car, so don't do that. Again, flip down ladder here just snaps in over on the side. It would be nice if you could resin print that, but you don't have to. The cab prints in one giant piece, and then the side is separate. It's got separate window bezels, and there are templates included to cut the windows from clear plastic, so you can glue those in with something like this crystal clear, which works really nice because it doesn't fog up like super glue can, or your choice of canoply glue. Glue the windows in, and then you can screw this side on it. Again, you could resin print or FDM print these parts. The tray is one giant print. It's meant to print vertically, and then the back half is a second motor tray with some additional trim pieces bolted onto it. This is a very similar assembly to what I showed you in the rear. It's again the same motor, so you got 4 of the same motors in this model. And you can see the underside has got some skid plate detail here. Ignore the block. Again, that's just for the purposes of holding it upright in this video. And I think that's about it. Items like the grill can be printed with lower infill. Fenders could be printed with lower infill if you wanted. Again, though, the weight is nice, so if you're willing to spend the money on filament, the more the better. You could even print them solid if you were that ambitious, but mine are pretty hollow. I think these cosmetic parts I only printed at like 15 or 20%, so plenty sturdy. They don't do anything other than look pretty. These bolt on easily. Each half is held on with 3 bolts underneath, so 3 socket headed cap screws underneath, and this fender comes off. I've set everything up inside with Wagos to make the wiring easier. Certainly you could solder everything. You can see there is a bit of a rat's nest in there with all of the ESCs inside, but there's plenty of room, and again, you can kind of set it on the edge of the bench here, take these screws out, and this will come right off, and then you can do all your wiring and get to everything. Tried to make it pretty serviceable, pretty easy to work on, and hopefully pretty easy to build. I'll let you be the judge of that should you decide that this is something you want to tackle. All right, well, I think that is enough of me rambling on. By now you've probably formed an idea in your head if this is a project you want to take on or not. Hopefully I get to see some of these out in the world getting built. It's something that I really wanted. Hopefully some other people enjoy building them as well, and I get to see these maybe even at a show someday running around. That'd be a pretty neat thing to see. Pretty easy to find on Facebook. If you've got some questions, hit me up on that Capital Customs page. Reach out to me, send me a message. I can be pretty responsive most of the day and try to get your questions answered. Looking forward to see what you guys come up with and what you think of the model when it gets out there in the world. Thanks for watching.